Okay, here's what we've learned so far. So I've introduced the idea of the mole to you. Okay, I drew mole as this little house because mole is where we're going to go back home. It's kind of like home base. Okay, so what we're doing in this unit is we are trying to go from unit to unit. We are trying to use this triangle to go from different places, like how many atoms make up a certain number of grams. Okay, or how many if I give you a certain amount of grams, how many liters of gas will that be? Okay, so we are going to use this triangle to go either from grams to mole, and you can stop at home, or you can go mole to grams, and you can stop there. Any of these places are kind of like a checkpoint, okay? But you can't jump from like atoms to grams. You have to first go through home base before you go to grams, okay? So we have learned, the first thing I taught you is how to go here, right there. We learned what a mole was. We learned that it is 6.02 times 10 to the 23rd pieces. So normally our pieces are going to be like this: atoms, molecules, or ions. And I gave you a conversion factor for that. You can use it two ways. You can use it where mole is on top if you're searching for how many moles, like if you're trying to go this way, you can use it where mole is on top. Or if you're trying to go the backwards way, back up to atoms, you could use it where mole is on bottom and particles is on top. Particles here can stand for atoms, molecules, or ions. But it's very important to realize that this number, the 6.02 times 10 to the 23rd number, only belongs in this transition. It does not belong in the other transitions. So what that means is you can't just put 6.02 times 10 to the 23rd in random places. It is only when you're asked for how many particles or pieces, like atoms, molecules, or ions, make up a mole. Today you're learning about grams. Grams is a measurement of weight, kind of like pounds is. So it measures the mass that is present, okay? So this is not measuring pieces. This is measuring how much the pieces weigh, all right? So we have different ways that we can go back and forth between mole and grams. If you want to go from mole to grams, we will use the conversion where mole is on bottom and grams is on top. Now this number is going to change with every element, okay? So elements all have the same setup on the periodic table. Let me draw one for you real quick. So if I'm dealing with sodium, this is what sodium's box looks like on the periodic table. Na symbol, 11 is the atomic number. This is your atomic mass. This number is also what's called your molar mass. So this is the number that would go right here. But we're going to round it to the nearest whole number unless this number is a 5, and then we'll keep that 5. So it's going to be 22.9, so we're going to round up to 23. So that is the number that would go right here, 4 grams. Okay? This would be when we're trying to go from mole to grams. If we want to go the opposite way and go grams back to mole, we just use the inverse of this fraction, where we put grams on bottom and mole on top. Notice that no matter what I'm dealing with, the number 1 is always with mole. When I'm dealing with a conversion factor, since mole is your home, the number 1 is always with mole. The other number is either from the periodic table if we're dealing with grams, or if you're dealing with this, it's going to be Avogadro's number, 6.02 times 10 to the 23rd. So if I want to go from grams up to mole, I can use this version of the fraction where this number is off the periodic table, and I have we're talking about sodium, only sodium, it would be 23 grams under 1 mole to get me back to moles. Now, what if I give you a certain number of grams and I want to know how many atoms you have in that number of grams? Well, you can't jump straight from grams to atoms. So you would have to use this conversion to go from grams to mole. Then you would have to use this conversion to go from mole to atoms. So we would have 2 steps right there. Okay, so the next thing in our conversion factors are learning how to go from moles to grams, or grams to moles. Okay, the G stands for grams, which stands for mass. So the question says how many moles are in 2.5 grams of Na, sodium. So again, I'm going to do the same thing I did last time, where I write down what I'm given, which is the number given 2.5 or 25.2 grams of sodium. You see that it's important to put G for grams and Na to indicate that we're dealing with sodium. What are we asked for? Our goal is to determine how many moles. So we're trying to go from grams to moles. The way you go from grams to moles, or you use its molar mass. You use sodium's molar mass. The molar mass is the amount of grams in 1 mole. Okay? It's how many grams are in 1 mole, and you can find this just for a single element. You can find it by looking at the periodic table. Okay? So on the periodic table for sodium, this is what sodium looks like. You have Na, the name. You have 11. 11 is the atomic number, which stands for how many protons. This number down here, this is your atomic mass. So we're going to round it to the nearest whole number. 22.990 rounds to 23. Okay? 23 grams of sodium equals 1 mole of sodium. So we're going to use this as our conversion factor. So when you're setting it up, again, you're just going to set up the little fraction bar. If you see it in blue, I have my fraction. And you're going to write what you're given right here. You're going to write it on the top of the fraction. 25.2 grams. And then I forgot to put the Na, so I went back and put it. But it's supposed to say 25.2 grams of Na. Okay, it's important to write the gram, the unit, and what I'm dealing with, sodium. So since grams is on top, I'm going to put grams on bottom. But the number that goes with grams is always going to be the number off the periodic table for this element. So 22.990 rounds to 23. I'm trying to go from grams to moles. So I used 23 grams of sodium, and I know that that is equal to 1 mole of sodium. Okay? So now the grams canceled, and now I have mole on top. So now this is what I was looking for, so I can write an equal sign, and then I just solve my math. So I say 25.2 times 1 divided by 23, and your calculator should give you 1.096 moles. Okay, so this time we're doing molar mass again, but we're going the opposite direction. So it says how many grams of water are in 1.5 moles of water. So our given is 1.5 moles of water, H2O. Our goal is how many grams. So to go from mole to gram, we have to use the molar mass. Now the molar mass of water is it's a compound. So we have to think about the hydrogen and the oxygen that makes up the water. So on the periodic table, we will need both hydrogen and oxygen. So when you are finding the molar mass of a compound, you are going to take each of your elements. If there's 20, you'll write 20 elements, okay? You'll take both of the types of elements. You'll say how many are in the compound of each. There's 2 hydrogens, there's 1 oxygen. You will then multiply that number by the mass. Well, according to the periodic table, hydrogen's mass is 1 gram. Oxygen's mass is 16, it rounds up, 16. So 1 times 16 is 16, 2 times 1 is 2. Now this is the total mass of water, so I'm just going to add these numbers up and I'll get 18 grams per 1 mole. So this is the same format as I showed you in the previous videos, where we can say 1 mole over whatever how many grams, we just calculated to be 18. So 1 mole over 18 grams of water, or we can say 18 grams of water over 1 mole. We just need to figure out which side we need to use for this problem. So to your problem, again, I have my factor labeling set up. Okay, I'm going to write what I'm given, 1.5 moles of water right here. Since moles of water is what I start with, I need to put moles of water on bottom. So there's my mole of water. Now I'm trying to go from moles to grams, so I'm going to put a 1 with it because that's what my formula looks like. So I'm going to choose the side that has moles on bottom, which is this side. Now the gram on top is what I just calculated, 18 grams of water per 1 mole. This is the conversion of using molar mass when we're trying to go from moles to grams. So then your moles will cancel and you're left with 1 and 1.5. You're also left with 18, those numbers. And then the gram of, here, let me do this. Mole is divided by mole. So then you're left with 1.5 times 18 grams of water divided by 1. So if you say in your calculator 1.5 times 18 divided by 1, you will get 27 grams of water. Okay? Okay. So I've set up one where we are going to have to do multiple conversions, but I'll tell you why. So we have the question of how many atoms of iron are in 70.2 grams of iron. So again, we're going to do the same thing where we write our given, 70.2 grams of iron, and we're asked for atoms. But this goes back to this chart I told you. Is there any way of going from grams straight to atoms? There's not. I have to go from grams to moles, then I can go from moles to atoms. And remember, to go from grams to moles, I use one of these conversions where the number is the number off the periodic table. So that would get me to moles. And then to get from moles to atoms, I have to use Avogadro's number. So I'll be using one of these conversions. Okay? So I'll show you when we do both. So that's what I wrote right here. You can't go straight from grams to atoms, but you can go grams to moles by using the molar mass, and you can go moles to atoms by using Avogadro's number, the big number. So I wrote iron on here so that you would know that this is the mass of iron. So when we start our fraction, our factor labeling, we're going to write what we're given. This is what we're given, 70.2 grams of iron. Well, since grams of iron is on top, that means we are going to put grams of iron on bottom, okay? Now, the number that goes with grams of iron is off of the periodic table, this molar mass. So basically what I'm doing is I am using this version of this card to go from grams to moles. So this number is off the periodic table, and for iron, it is 56 because 55.8 rounds up to 56. So there it is. And then remember, we're going to moles, so the number 1 will go with moles. 1 second. So since moles on top, that means we're going to put moles on bottom. So the last place we're trying to get to is back up to atoms. So that's where I said that we are going to use Avogadro's number, because once we got to mole, now we're in the middle. We need to go up to Avogadro to get to atoms. So I'm going to use the version of this card that has mole on bottom, 1 mole. I'm going to use 6.02 times 10 to the 23rd so that I can get to atoms. So then I finally have atoms at the end, and that means grams of iron cancel with grams of iron. Mole of iron cancels with mole of iron, and the only unit left is atoms of iron. So that is what my answer is going to be in, which is what I was looking for. So then when you put this in your calculator, you will put 70.2 times 1 times, open parentheses, 6.02 times 10 to the 23rd, close parentheses, equals. Then you will take that answer that you get and divide it by 56, divided by 56. And you should get something similar to this, 7.54 times 10 to the 23rd.